Ladies and gentlemen, to ensure the safety of energy storage systems, or ESS, the industry is shifting away from traditional post-fire suppression methods toward a new paradigm: proactive thermal management using sheet-type fiber optic DTS sensors. As you can see, these ultra-thin sheet sensors wrap directly around the battery cells, enabling highly precise temperature monitoring. By detecting abnormal heat signatures at a very early stage, the system can immediately identify potential risks and prevent fires before they occur. This advanced safety architecture represents a major step forward in enhancing reliability and safety in the future energy industry. As the energy density of energy storage systems continues to increase, the response delay and detection blind spots of conventional BMS and reactive sensors have become critical safety challenges. NWC's sheet-type DTS addresses this issue by using non-conductive fiber optics, enabling ultra-precise temperature monitoring with 0.5 meter spatial resolution, completely free from electromagnetic interference. This system detects abnormal thermal signatures during the golden time before gas venting occurs, allowing potential hazards to be identified at the earliest stage. By introducing an independent optical safety layer, NWC's technology overcomes the limitations of existing systems and establishes a new dual-layered defense architecture for ESS safety. Approximately 68% of ESS fire incidents are classified as undetermined causes due to the complete destruction of assets. This makes root cause analysis virtually impossible, increasing systemic risk across the entire industry. Large-scale incidents, such as the recent aerosol factory fire, clearly demonstrate how devastating an information blackout can be when early warning signs of thermal runaway fail to be detected. Ultimately, risks we cannot see cannot be prevented. This is why the industry urgently needs data-driven, innovative solutions capable of providing visibility into the critical moments just before a disaster occurs. Conventional gas and smoke sensors typically activate only after off-gas release or thermal runaway has already begun, making them insufficient to prevent significant asset loss. As illustrated here, the detection gap, from the battery stress stage to just before thermal runaway, represents the critical golden time where early intervention through DTS technology becomes essential. By monitoring thermal changes, the root cause, rather than the symptom of smoke, in real time, the system enables proactive intervention to stop thermal runaway propagation before it escalates. This capability is the key to achieving true system stability and safety. Traditional BMS architectures rely on point-type thermistors, which create critical spatial blind spots beyond their limited sensing range. As a result, internal short circuits and early signs of thermal runaway occurring outside these points cannot be detected immediately. In addition, the potential loss of safety functions during software failure, combined with response delays caused by sensor thermal mass, further undermines the reliability of the system as a fire prevention mechanism. Ultimately, the BMS should be recognized primarily as a performance optimization tool. Its structural limitations make it inherently vulnerable when tasked with dedicated fire safety protection. Our sheet-type fiber optic DTS transforms the entire battery surface into a continuous sensing layer, enabling precise monitoring with no blind spots. Optical fibers embedded within a flexible CFRP substrate maximize thermal coupling, overcoming the limitations of conventional linear sensing cables. With direct contact to the battery cells, the system ensures exceptional thermal responsiveness. As a result, it provides a real-time temperature profile across the entire battery module, significantly enhancing overall system safety and reliability. This system combines the Raman scattering phenomenon with OTDR technology to precisely calculate temperature by analyzing the intensity ratio between Stokes and anti-Stokes signals within the optical fiber. With an excellent spatial resolution of 0.5 to 1.0 meters, it can accurately pinpoint the location of thermal anomalies. A fast update cycle of under 20 seconds enables continuous real-time monitoring. As a result, the system maintains a high temperature accuracy of plus or minus 1.0 degrees Celsius, reliably capturing the thermal behavior of critical equipment. Unlike conventional linear sensing cables that rely on point contact, the sheet-type sensor achieves broad surface contact, enabling instantaneous heat transfer and highly precise monitoring without delay. Its ultra-slim 0.2 mm sandwich structure protects the optical fiber within layers of CFRP and resin, providing strong resistance not only to physical stresses, such as vibration and expansion, but also to electrolyte leakage. This optimized form factor ensures the highest level of reliability for battery systems, even in the most demanding environments. Preventing fire propagation in ESS and EV battery systems depends on detecting abnormal conditions within the golden time before off-gas generation occurs. DTS technology provides early warnings more than 30 seconds in advance, identifying thermal anomalies at stage 1 and stage 2, well before gas sensors can respond. By enabling intervention at this early stage, the system can fundamentally prevent thermal runaway from developing. This level of precise early detection is a critical technology for preventing large-scale fire incidents and maximizing overall system reliability. To address potential failures in the electrical pathway of the BMS, we have implemented a dual-layer safety architecture using an independent optical pathway. Even if the BMS fails, the optical DTS system can immediately trigger a physical hard stop, securely shutting down the power conversion system. By introducing this independent optical safety layer, the system overcomes the inherent limitations of digital control systems and delivers hardware-level reliability. This represents a next-generation safety solution for critical battery and energy systems. Copper-based sensors are inherently vulnerable to electromagnetic interference and high-voltage surges, making signal distortion unavoidable. In contrast, optical sensors made from non-conductive silica glass provide complete immunity to external electromagnetic noise. Thanks to these physical properties, even in environments with lightning strikes or intense PCS switching noise, the system maintains perfect signal integrity without any risk of electrical short circuits. As a result, it ensures high-voltage safety while enabling highly accurate data transmission, significantly enhancing the overall reliability of the system.
Among existing battery safety diagnostic technologies, sheet-type DTS is the only solution capable of detecting early fire signatures during the preventing stage before gas venting occurs. By adopting fiber optic sensing, the system completely eliminates electromagnetic interference while providing precise localization with 0.5-meter spatial resolution, enabling full coverage without blind spots. Going beyond the limitations of conventional BMS thermistors and gas or smoke detection methods, this technology delivers the fastest and most accurate pinpoint detection available for battery safety monitoring. Global standards such as NFPA 855 2023 edition and the International Fire Code IFC now strictly require early warning systems and real-time data transmission to prevent thermal runaway propagation. DTS solutions provide the high-resolution thermal data essential for UL 9540A certification, fully supporting the rigorous fire propagation testing process. By establishing a continuous thermal monitoring framework, operators can not only ensure regulatory compliance, but also achieve tangible economic benefits, such as improved insurance eligibility and reduced insurance premiums. Compared with traditional approaches, DTS technology delivers approximately a 64% reduction in total cost of ownership over a 10-year period. Fiber optic sensing requires virtually no replacement or recalibration, and when combined with condition-based maintenance, it significantly minimizes the risk of asset loss while maximizing operational efficiency. This results in a compelling return on investment, clearly demonstrating long-term asset protection and economic value that far exceeds the initial capital cost. NWC's sheet-type DTS proactively prevents ESS fires through precision monitoring with no blind spots and an independent dual-layer safety architecture that remains operational even if the BMS fails. In particular, its early warning capability, securing the critical golden time before thermal runaway occurs, represents the core of a next-generation safety architecture, going far beyond traditional reactive approaches. With its three key values, precision, independence, and timing, sheet-type DTS sets a new benchmark for ESS safety standards.